is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hello and welcome everybody to Sky Tour Radio here on kgraradio.com. I'm your host, Mark D'Antonio, here with my effervescent, I like that word, co-host Amanda Curran, and our recurring co-host, Daryl Mason. How are you doing tonight, Amanda?
I'm well. How are you?
Good. And Daryl, how are you?
I'm good.
That's great.
Effervescent means fizzy, so Amanda's fizzy tonight.
Yeah. That's the word I like. I said she's effervescent, so she's fizzy. Kind of like fizzy lifting drinks from Willy Wonka, right?
Sure.
Yeah. So,
Hi, Amanda.
Hi, Daryl.
Amanda and Daryl have a very, very good friendship. They, Daryl has been very good to Amanda in teaching her astronomy when I have said things that have been too much for her, which is not that often, but sometimes.
Oh.
Yeah, no, it's okay, Daryl. You call it what it is. You're good at helping people figure things out, which is kind of why I wanted to have you with us on this program.
Well, thank you.
Yeah, of course. It's the way it goes.
Amanda asked very intelligent questions on our last stream, by the way.
That's correct. And our last stream was on Sky Tour live stream, which is, I'm glad you mentioned that, because if you like Sky Tour Radio, then why don't you all subscribe to, if you haven't already, Sky Tour live stream, which is on YouTube, of course. And what is Sky Tour live stream? Well, it's a clear night journey into the wonders of the deep sky. It's all courtesy of the research-grade telescope here at the John Zach Memorial Observatory that we run here in picturesque northwestern Connecticut. Now, it'll be moving to Arizona in the next year or so. But until then, we're here in Connecticut, and we can see stellar birthplaces, see the remnants of dead and dying stars, view the glittering jewel boxes, which are clusters of stars in the night sky. Our last stream, we actually showed a globular cluster that had several 100,000 stars in it. It was beautiful. Just beautiful. It looked like a glittering, exploding snowball of stars. So it's also a stream, by the way, where you guys can take charge, those of you that are watching and listening. If you're in the chat room, you can give us a request and say, hey, can you go check this out? And if it's something that's up, we will go. We've done that often. And Amanda knows she sometimes takes those requests, right? So it's a really cool experience. Yeah.
I try.
Yeah, we do. And sometimes we get to you and sometimes we can't because I'm in the middle of going through some long-winded spiel about a planetary nebula or a stellar nursery, but all in all,
you have given me permission to break in the past, so I'm going to hold you to that if I get a really good question.
For example, exactly so. And then that's I've done that on purpose because I know that sometimes I need to be interrupted. So you guys in the KGRA audience are probably among the most knowledgeable audiences I've ever talked to on Earth, and I've spoken to a lot of audiences. I get really phenomenal questions in the KGRA chat. And so, to that end, I like doing some nice things for you. So if ever you're interested, you can check out our online store at fxmodels.com or the FX Models Planetary Replicas page on Facebook. And you can check out our very cool 3D printed moon, Mars, and Pluto landscapes and craters, all taken directly from NASA space probe data. And these are not just sort of fly-by-night little crater plates that we make. These are accurate. These represent the actual crater in its elevations and so forth. So when you look at Pluto, for instance, when New Horizons went by, we can actually see all the detail of the Barre Montes mountainous region, for instance. Or on the moon, we can look at Tycho crater or Copernicus or Plato and see all of the detailed craters around it and the detailed landscape. These are not, like I said, these are good high-resolution prints. And our process of replacing lost data is something that we are kind of proud of, that allows us to showcase the crater like never before seen in a 3D print. So, if you have any questions about any of this or you want to talk to us about tonight's show, you can email us at skytourradio@kgraradio.com, and you'll get me or Amanda, and we will promptly respond to you if we can at that moment. Otherwise, we will make sure we get back to you at some point within that week. So, what are we going to talk about tonight? Well, we have an exoplanet roundup for you tonight, which is kind of interesting because we're going to revisit an earlier one because there is new, unbelievable, startling revelations about this new exoplanet. And then we're going to do a little revisiting of that black hole that was imaged in Messier 87, that very large elliptical galaxy in the constellation of Virgo, 55 million light years away. And why are we going to talk about it again? Well, we're going to talk about it again because there's more to say. There's some things that did not get brought out, I don't believe. And I think that this broadcast tonight will help clear those up. So to our listeners who are interested in black holes, that's going to be the segment you'll want to listen to. Then after that, we're going to talk about something else. And this is something down to earth. And it's called geomagnetic reversal. Now, those are big words, but you've probably heard about it when it's been stated as pole shift. What is pole shift? And when could we ever expect to see it again? Is it happening now? Has it happened in the past? How many times? And what are we looking at? We're going to go through what these are and what it is. I mean, and as I said, it's going to be a fun night. And then wherever the conversation takes us with Amanda and Daryl and myself, well, then we'll be happy to check it out. And if you have questions, please don't forget. You look out in that KGRA chat, put your question in there in all caps, and we will answer it on the spot if we can. And Amanda has the permission to interrupt me to ask a question. You got that, Amanda?
I do.
See?
And we're now with the new Discord chat. It's the new KGRA chat up and running now, so do join us there. It's at Discord. Search KGRA. And that's where I'm following questions now. So for those in Discord, if you have questions, just let me know. I am in the room to grab.
Thank you.
May I say something?
Yes, Daryl.
I will not be in chat tonight, people. I apologize. I am resistant to change, and I think Mark and Amanda are going to try their darndest to drag me into the 21st century here. But I am not in Discord tonight, so Amanda, if there are any questions I need to respond to, please let me know.
Oh, of course.
Thank you.
She'll do that. Very good.
They all miss you in there, by the way, Daryl. A few people were already looking for you.
And they're aiming.
Yeah, I bet.
That's funny. So let's get going here on Sky Tour Radio tonight. I got to tell you, this has been kind of a sort of a busy week. We've had a lot of rain here, and tonight is the first night in many that the sky is bright blue and clear. The observatory is already open, and after the broadcast, I'm looking forward to going out into the observatory and getting it ready for a night of streaming. But we're not going to go that long, probably only about an hour and a half to 2 hours, because I do have to be up early tomorrow. But, we'll be able to talk about a few things. We'll be able to show you some neat objects in the sky. And we will be able to have some fun tonight, I believe. So that'll be for later on. So both Daryl and Amanda are invited. I know Amanda has a comedy show to do. And Daryl may...
Funnies on her radio.
Yep. And Daryl will be hopping back and forth between the two probably. And maybe he'll stay with Amanda. Maybe he'll stay with us over in SkyTour Livestream. Whatever the choice is, it will still be a wonderful night for all.
Mark,
anyway,
Amanda is cuter than you.
I am certainly hopeful that's the case. I mean, that's very important, don't you think?
Well, I'm just saying. We'll see where I wind up tonight.
No problem. I've managed it for a long time before, so I'm not worried about it. If you want to do that with her, go right ahead.
We'll see.
Okay. So tonight, what we're going to talk about first is the exoplanet roundup that I mentioned. And I mentioned it was going to be something that we had previously seen. And it is. Tonight, we're going to talk about Proxima B. Now, wait a minute. We've talked about Proxima B. We have the Alpha Centauri star group, which is the A component, that's capital A, the B component, capital B, and then the C component, capital C. A and B are stars that are kind of like the sun and a little bit later type than the sun, whereas the sun's a G. The other stars are a little bit later, down around the K. And then we have Proxima, which is the capital C. This is a triple star system, as you might recall. And around that little red dwarf, which is what it is a planet. And they call it Proxima b. Proxima is the name of the star, the capital C star. So that third star is this little dwarf M star. And on the scale of our spectral classes, which Amanda knows so well, M stars are at the end, the lowest intrinsic brightness, which we call luminosity, the lowest temperature, and the longest lived. And they can percolate out in the universe, fusing hydrogen into helium for not millions, not billions, but trillions of years, which is a lot longer than a star like our sun. And these red dwarf stars, they comprise over 80% of the stars in our galaxy. It's over 80%. And they're usually pretty unstable. They have a lot of high energy ultraviolet flares, Now, Amanda, if you'll be so kind as to tell everybody the spectral classes of the stars so they can get this into perspective.
I thought you were going to skip that part. I was so disappointed.
No, not at all. Go for it.
It's OB and FGKM.
Wait, say that again?
OBAFGKM.
That's correct. Okay.
Okay.
I thought you said something different. And
okay.
What does that signify?
It's "Oh, be a fine guy, kiss me," or "Oh, be a fine girl, kiss me."
Right.
The G is interchangeable depending on your preference, but it really works. It really, really works.
Well,
"Oh, be a fine guy, kiss me."
Yeah, it helps you remember. Now, in particular, what are the properties of the stars from O down to M? Do you remember?
I do. The O stars are the biggest and bluest and hottest. And the M stars at the bottom of the scale are the smaller, cooler, redder.
That's exactly right.
Okay.
And everything in between sort of follows suit. The B stars are a little bit cooler, a little bit smaller. The A stars are less so in temperature, and all the way down to M, as Amanda just said. Now, this scale and the spectral classes are just half of the information. The other half is something called the luminosity class. The spectral class is the color. OBAFGKM represents a color. So we have bright blue, lesser blue, white, yellowish, orange, and red. Okay, and those represent the letters, are represented by the letters. Now, the stars, if they're normal stars, it means that they are fusing hydrogen into helium in their cores. Our sun is a normal star. Alpha Centauri stars are normal stars, all three of them. But some stars, like Betelgeuse, are not normal stars. These are stars that are past the point where they have burned or fused hydrogen into helium. And they started fusing helium into other things, and the star swells up into this massive red giant. And they're called giants or supergiants. And Betelgeuse is a red supergiant, and it's probably going to end its life as a supernova, where the star will explode because it'll suddenly run out of nuclear fuel, and the entire gravity of the star will force it to collapse, and it will all bounce off this inner core in the middle, and boom, it's going to shoot outward with all kinds of shock waves. And someday, some people on Earth will see it. It won't affect us because it's over 450 light years away. But that said, so Betelgeuse is a red star, but it's a supergiant, and Proxima is a red star, and it's just a normal little hydrogen fusing dwarf, as they call it. So we can't just look at the color. We have to look at the other evolutionary state of the star. Okay, so Proxima is a dwarf. That is to say, it has a luminosity class of Roman numeral 5, which is the V. All right. And Betelgeuse, on the other hand, is a supergiant who has a luminosity class of Roman numeral 1A. Okay, so it's a really, really big star, and it represents a very different state of the evolution, although it's still the same color as Proxima. So going back to Proxima, what does this mean now? It means that Proxima Centauri, we know as a little red dwarf. These red dwarfs are very well known to have energetic outbursts of ultraviolet energy. Well, UV isn't good for life. It can sterilize most life on the planet if it got to our surface, but luckily, our magnetic field and our atmosphere help hold it at bay. Now, traditionally, when we talk about M-type stars, we say, well, they can support life, and there's more of that kind of star than any other star in the galaxy. As I said, over 80% of the stars in our galaxy, and most galaxies, as a matter of fact, are these little red stars. And traditionally, they can't. They can support life, but the probability was lower because of the ultraviolet radiation. Well, guess what? Things are not as they seem, as it turns out. There's a new study that shows some very, very surprising results. It turns out that Proxima b probably could support life after all. Now, why? Even though Proxima has these ultraviolet outbursts like any other red dwarf star, we see that something has changed in the way we think, because we looked at the Earth to figure out whether our own history showed any kind of increases and changes in the ultraviolet radiation bathing the planet. And it turns out that there has been. And solving that conundrum of whether life can exist on Proxima b, came through this examination of our own planet's ancient history. It turns out that comparing the early Earth's ultraviolet levels to these M-star radiation levels, early Earth actually had higher levels than most all other M-stars have. So this means that even though we have this higher radiation, look at all the variations in life that we have here now. Isn't that incredible? This variation is something that we thought was due to a fairly quiescent star, our own. But it's not. Our star has actually had a very turbulent past, and it has had ultraviolet emissions and ultraviolet flares that threatened life. So Proxima is 4.8 billion years old. We're 4.6. So that means that life on Earth is incredibly varied. So perhaps life on Proxima b could be incredibly varied as well. Now, curiously, let's take a look at this now. Because of the variation in life on the Earth, we ask, why is it so varied? Now, well, we know how evolution works, okay, and we've suffered, and life forms on this planet have suffered many different types of mutations. But curiously, all the life forms on the Earth are remarkably similar in some aspects. Most of these multicellular life forms and larger life forms all exhibit bilateral symmetry. We've talked about this before. The way they interact with their environment is through a symmetric body structure. 2 arms, 2 legs, 2 eyes, that kind of thing. And it's also carbon-based. And it's full of deoxyribonucleic acid. That's what drives the life forms here. That's what actually drives life. That's called DNA, of course. Now, within DNA, we have something called CHOMPs, CHONPS, carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. Now, CHOMPs is a very important set of chemistry because these and all the chemical bonds and all the chemical constructions that come from it are what create DNA and what create the life on this planet. So it's really the core set. And carbon, as we've mentioned in previous shows, is the granddaddy of all periodic table elements because it has more bonds available to it and can bond with more things in the periodic table than any other element. Okay? It's really the most versatile element in the entire periodic table. And it just so happens that the universe provides a template for carbon-based life. Sort of stands to reason, doesn't it? Carbon is the most versatile, so if there was going to be some type of evolution of the universe, maybe they would start out with maybe life forms might have tried silicon-based life or whatever, but then silicon doesn't have the kind of bonding capability and variation that carbon does. So carbon ended up being the winner, hands down. Now, even so, when all that happens and we have DNA, we know that DNA can be damaged by radiation, right? However, life on this planet persisted regardless. Now, evolution is defined as mutation followed by adaptation, right? You have a mutation. Now, the question is, what caused these mutations? Could it have been higher ultraviolet levels hitting the Earth at times? So if mutation from these higher levels of UV radiation getting to the Earth in the earlier history of the Earth, well, then that means that more opportunities to adapt were also presented. And survivability depends on the organism's ability to thrive under the new conditions. And that's the adaptation part of it, isn't it? So mutation and adaptation. So maybe we've been looking at this huge number of mutations followed by a huge number, even more, of adaptations. And perhaps these early levels of UV radiation on Earth are responsible for those many variations of creatures based on the same original creature. What's that mean? It means that you sometimes have a common ancestor, all right? We talk about humans as being hominids and hominins, and you can actually see you can trace our history back along a tree to a common ancestor along the way. You can trace certain salamanders and other life forms back to common ancestors. Well, what is that common ancestor? That common ancestor, where'd it go? Well, birth rates among those common ancestors either dropped for some reason or they mutated to a different form. And perhaps that mutation was caused by this UV radiation. We don't know. And that common ancestor would spawn perhaps dozens of branches, parallel branches of variations on the same animal. And that's called adaptive radiation. And many variations that arise from one common ancestor is what we have on this planet in a lot of cases. So a possibility. There's just a possibility now. Tremendous variation of life on the Earth is due to the higher levels of the UV radiation in the past, maybe, right? I think that's a pretty interesting thought. And because M stars, the most populous stellar type, with lots of UV radiation outbursts, okay, these M stars might actually be, I guess, a little percolators that create life and create all the many mutations. Maybe the universe is mutating life because M stars are so prevalent in the universe. We don't know that because we don't have any M stars close enough to examine planets with, not at this point. But, then if UV radiation is responsible for this large variation of life forms, then maybe there's more varied types of life in the universe than we ever thought possible. Think about that. Isn't that crazy? And
Mark, I'm sorry. Can I jump in real quick? I'm going to play a doubting Thomas here. In the recent news you've talked about, has anything changed in the known nature of Proxima B? The last I had heard, the planet is tidally locked. It has basically scorched Earth due to the prevalence of the UV flares from Proxima. That maybe something could live near the Terminator on the planet, the sun side versus the
sure
shadow side. Has anything changed as far as Proxima B itself goes?
No,
we know of?
Well, what has changed is our outlook on UV bathing. That is, a planet being bathed in UV light. Now, a lot depends on. There's a couple things we have to consider here. We don't know anything about whether Proxima B even has an atmosphere. We don't know anything about how thick it is. Okay. We also don't know if Proxima B has a magnetic field. Both of those things are instrumental, in fact, crucial, to allow life forms to persist in a scorched earth, so to speak, situation. We don't know the actual temperature on Proxima B, but depending on the atmosphere and the magnetic field, Proxima B could be cooler than we thought, or it could be a lot hotter than we thought. Now, because it's tidally locked, yes, the noonday sun is always going to be the noonday sun. And being that it's always the noonday sun, well, of course, it means also that we have we have some other concerns, and that is that if we have a terminator where we want to go to, say, watch a perpetual forever sunset, well, we're not going to be able to do that, will we? So I have to say, the night side might be the best bet, and the atmosphere, if it's thick enough, it could actually conduct a lot of the heat around to the back side. A study was done to show that that works that way.
Cool.
Yeah, pretty cool. So that all said, that's the visit to Proxima Centauri. And when we get back on Sky Tour Radio, we are going to talk about a few more really cool things that we talked about at the top of the hour when we first started. But until then, I'll see you in a few moments.
Balance of Nature's fruit and veggie capsules contain 100% vine-ripened fruits and vegetables, tested pure with no pesticides, fillers, or additives of any kind, and are the most effective whole food supplements on the market today. You might ask, how can over 10 servings of 31 different fruits and vegetables fit into 6 vegetarian capsules? Fruits and vegetables are on an average 85% water. Balance of Nature uses cold vacuum technology to remove the water, leaving only the whole food. We don't use any heat, air, or light drying methods that damage nutrients. Our cold vacuum technology maintains 99% of the fresh fruits and vegetables' original nutritional value. Along with diet and exercise, Mother Nature provides fruits and vegetables to help us maintain good health.
To order, go to balanceofnature.com or call 1-800-246-8751. That's 1-800-246-8751 and use discount code TALK.
Okay, nurse, let's get this man to the ER stat.
Right away, doctor.
We see this every day. Heart attack or angina pain due to blocked and clogged arteries. Chelation can remove obstructions or blockages from arteries and help avoid painful and expensive surgery. Now there's Angioprim. It's a liquid oral chelation product that you take with juice. You start to feel the results fast. Angioprim increases blood flow all over the body, and that means more energy and strength to take on the day with less aches and pains. 60 years of research has gone into chelation, and Angioprim is the result. A safe and easy way to unblock your veins and arteries from buildup that slow circulation.
Paging Dr. Jones. Please report to the emergency room right away.
Log on now for a special radio offer from Angioprim. That's angioprim.com/radio. ANGIOPRIM. Angioprim.com/radio or call 877-882-7221. That's 877-882-7221.
Join me, George Norrie, in Indian Wells, California for the 7th Annual Contact in the Desert UFO Conference, May 31st to June 3rd. Contact in the Desert is an epic weekend of adventure filled with exciting explorations into ancient aliens, human origins, crop circles, UFO sightings, disclosure, and the newest evidence of ongoing contact. This amazing weekend offers over 50 lectures, 40 workshops, 8 exciting panels, special events, and a luncheon that I'm hosting. Contact in the Desert also features leading experts including Giorgio Tsoukalos, David Wilcock, Linda Moulton Howe, Michael Tellinger, Eric Von Daniken, Doc Wallach, and many more important researchers and scientists in the field. Contact in the Desert is your place for inside information. Join us at thecontactinthedesert.com to get your tickets today. It's time to make contact. That's contactinthedesert.com. Don't miss it. Contactinthedesert.com.
Hey everyone, this is Nick Redfern, and you're listening to Sky Tour Radio with Mark D'Antonio on the KGRA network, and so are the Men in Black.
Mainstream media's most wanted. KGRAradio.com.
I can't believe we're back already. Yeah, this is Mark D'Antonio. Welcome back to Sky Tour Radio. I'm here with Amanda, my wonderful co-host, and of course Daryl, our co-host, who is joining us more often these days. Daryl's perspective on astronomy is something valuable to me, and I think to all of you. So he
Definitely
joined us.
to me.
Exactly, and he joined us again.
Thank you.
You're more than welcome, because you are a master of your craft as well, and I think that it's worth celebrating that. So I just wanted to say, when we talked about earlier, we talked about the UV radiation, striking Proxima b, the planet that's around Proxima Centauri. And Daryl asked a question about whether the UV radiation would possibly bake the planet, and the answer is yes, it could. But again, the atmosphere has to be a certain thickness, and we know that some of these planets have very thick atmospheres, so the jury is still out. But there is a real good study. I think it was accepted in the Astrophysical Journal. I'm not sure, but it was talking about the fact that Proxima b is a likely candidate now for looking for life. Now, it might only be microbes at this point. We don't know, but we know how the explosion of life works and how that happens on our planet. And we know that once some life gets a foothold, it tends to snowball, so to speak. Now, moving forward and going 55 million light years away from the Earth, I want to run out to M87, which is Messier 87. It was I don't know if it was number 87. I think it was probably the 87th one he cataloged. But when Charles Messier made his catalog, he cataloged this in the 87th position, and it was a bright galaxy, but it was an elliptical galaxy. We talked about galaxies before. You can have spiral galaxies, you can have elliptical galaxies, spherical-looking galaxies. M87 looks like a spherical type, a very tight elliptical. So in other words, it's got many, 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 many stars, and it's a very big galaxy, and is right near the center of gravity of something called the Virgo cluster. But we'll talk about that in a minute. The thing that's in the middle of this galaxy, though, is a supermassive black hole. And if you've been following the news in the last week or two, you actually saw that, actually several weeks, you saw that there was imagery, finally, of a supermassive black hole for the first time in human history, seen in the center of this galaxy, 55 million light years away. Now, first of all, you say, well, how do you even get such a photo? I mean, how is that possible? Well, it's possible if you use 8 different telescopes, as they did, and if you keep observing the galaxy as the Earth rotates out from under it, and you just keep the telescope pointed at the galaxy, and then over time you get these 8 long swaths across the planet from each position on the planet where these telescopes are located. And those 8 swaths end up amounting to an 8,000 mile, the diameter of the Earth, 8,000 mile diameter telescope. Crude, but still a telescope. And I think that this is the principle by which we should carry out other types of research in the future. And I'm sure we will. Now, when we look at the galaxy, we actually were able to image an object in the galaxy 55 million light years away that was about 5 times bigger than our solar system. And I'll get to what that was in a minute, because I do have some interesting numbers to talk about with you. But let's talk about the architecture of where this galaxy is and what it's around and where we fall into this whole mess. Now, the constellation Virgo is where it's located, and that's and the galaxy is near the center, as I said, of the Virgo supercluster. What's that? A supercluster is a cluster of many galaxies. And not just a small cluster, but a very large cluster. And the Virgo supercluster is no exception. It has many galaxies in it, and we find that galaxies are usually found in groupings. The Milky Way galaxy is in something called the local group. We call it that. It consists of our own galaxy, the Magellanic Clouds, which are dwarf galaxies next to ours, but we don't get to see them in the northern hemisphere. That's a southern hemisphere pair of objects. The Andromeda galaxy, 2 million light years away. The Triangulum galaxy is similarly about 2 million light years away. And in total, in addition to those, we have a total of about 54, perhaps more, galaxies in our local group. I say perhaps more because we can't see through our Milky Way to what's on the other side. There might be other galaxies lurking out there that we don't see way, way out in the distance. But we can't see them because we're looking through too much, stuff that's obscuring it, like dust in our central Milky Way area. Now, our local group of galaxies is part of this supercluster called the Virgo supercluster. and the local group and the Virgo supercluster are also part of an even larger supercluster called Laniakea. Laniakea is Hawaiian for immense heaven or open skies. The interpretation has been gone both ways. And Laniakea consists of over 100,000 galaxies, and it's a cluster that is 500 to 100 million light years in size. 500 to 1,000, I'd say about 500 million, actually. 500 million light years in size, plus or minus 100 or so. And that's how big this cluster is. All right. And so in the center, it's not in the center of Laniakea, but it's actually in the center of the Virgo cluster. Near the center lies M87, Messier 87, this supermassive, super killer black hole lying in wait in the center of it. Now, when we talk about a black hole, we say, well, what is a black hole? And really, you can only think of it in terms of a mathematical construct. And we're not going to go into that at all because there's an intuitive way to look at it. Okay, first of all, a black hole is that. It's dark in the middle. Okay, so what? What does that mean? It means that there's so much gravity. The gravity, in fact, the power, the force of gravity is so strong in a black hole that it actually warps the physical space within which it sits. And that warping is what causes light to fold around it and bend around it. Light has no mass. It is particle nature and it's wave nature, but it has no mass. So, when the gravity of a black hole bends space, light is following the space. So it's akin to you driving in a car and going over rolling hills. If the car is light and the rolling hills is the warp space, your car follows the rolling hills. It goes up and down, up and down. It doesn't make a new path. It doesn't go straight through the air. It goes up and down. It follows the contours of the land. Well, light follows the contours of space. And if gravity causes space to be warped, then light follows the contour of that warp. So this is what happens in a black hole. The gravity becomes so powerful that where there's a certain point at which light itself can no longer navigate out of the black hole. It'll end up circling forever inside the black hole. And that location is known as the event horizon. And everything in a smaller radius than the event horizon is black as far as us trying to look into it. Okay. Outside, well, we can see all kinds of things going on. Outside the event horizon, we can see light circling the event horizon. That light will be in something called the photon sphere. Ooh, these big words. And the photon sphere is the area outside a black hole where light is momentarily trapped, making some orbits around the black hole. And then it can either go away from the black hole or go into the black hole. It's an even chance that it'll get trapped. And so...
I'm sorry, a question. The photon sphere, is that the same thing as the Einstein ring?
The Einstein ring versus photon sphere, I think they're the same thing.
Very good. Thank you. Sorry to interrupt.
No, that's okay. You're allowed to interrupt too, remember?
Okay.
It's not just Amanda that gets to do that.
We may talk about the Einstein ring later.
Okay.
Okay.
So the photon sphere that is outside this black hole is the area where light circles around, and you also have something called an accretion disk when there's matter that's circling the black hole. Not photons, but matter, like dust and debris and stellar gases that are moving and trying to circle the black hole, and the black hole is starting to pull them in. They tend to go planar. That is to say, they all tend to orbit in the same plane like the planets in our solar system. And this debris will move toward the black hole and begin to spiral toward it. As it collides with other particles and matter, it slows it down, and it ends up going into the black hole, increasing its mass. Now, the diameter of the black hole has a very specific size, and that size, and it's the size of the event horizon, basically. The event horizon, think of it as a spherical object. The event horizon is a certain size, and it depends on the mass of the black hole. All right? And this black hole that we're talking about here in this supercluster in Messier 87, literally, the event horizon from one side to the other is 1.5 light days across. Now, that doesn't mean much to you, but when I tell you that that's the distance light travels in, 1.5 days, you say, well, what is that distance? That distance is 260 astronomical units, and even that might not mean much to you. But it will if I tell you how far Pluto is. Pluto is about 50 astronomical units from the sun. 50. And this black hole has a diameter of 260 astronomical units. You do the math. The diameter of the event horizon here at this M87 supermassive black hole is 5.2 solar systems in diameter. More than 5 times the diameter of our solar system. Can you imagine that? And so when we talk about this event horizon, then we're talking about the place where light finally spirals close enough to this black hole as it's following the undulating terrain of space, basically, that it can no longer get out because the gravity is warping space so badly that it makes the light make a continuous circle inside the black hole, basically. It doesn't ever get out. All right. And so classically we say that the event horizon is that distance from a black hole within which light can never escape the black hole. Right? And as we said, that event horizon has its size is determined by the mass of the material consumed by the black hole. And in 1916, Carl Schwarzschild determined that the radius of the black hole would be related to the mass. He figured out a calculation for figuring out how big an event horizon would be. So you see, black holes have been known about since then. All right? And based on his work, we know the size of the M87 black hole, and it's what we call a supermassive at 5.2 solar systems in diameter. And now, if you want to know kind of how big that really is, just think of it this way. 5.2 solar systems in diameter, and it took us 15 years to get to Pluto. And we're talking about something 5.2 times the size. Okay? So, clearly, if you did the math, just across the diameter of that M87 black hole, it would take us 78 years at the fastest speed we can travel. That's essentially one human lifetime just across the diameter of the Messier 87 black hole. Isn't that crazy?
May I jump in here?
Yes.
Okay. There's some new information out. It's been out for maybe a couple of weeks. I just saw it today. If you consider that black hole, it's 1.5 light days diameter or radius, Mark?
The diameter, from what I understood, yes.
Okay. Some of this new information, hopefully we'll get into more a little bit later. That black hole masses about 6.5 billion suns. Its diameter is 1.5 light days, and it rotates in about 100 hours. Across that distance, it would take us 72 years to get across. That black hole is spinning once every 100 hours. That's about 4 days and 4 hours. Think about that.
Yeah, and just think about how fast you would be spinning, how fast you'd be rotating when you're out at that limit. 100 hours to travel that kind of distance is literally insane to think about. And you would think, well, if it's spinning that fast, why wouldn't it fly apart? And that gives you an appreciation for the immensity of the gravitational force holding it all together. And that's just something to ponder. Now, I think that black holes are fascinating. I actually, when I was getting my degree in astronomy, I doubted whether the black holes actually could really exist. And I came to realize that they can, but it was not easy to really comprehend, because you had to put aside all of your intuition and all of your thought processes that deal with logic, and just look at the mathematical calculations and let them sink in. Because when it comes to the universe will always surprise you. It will always violate every law you think you've made. Okay? And just like we didn't think we could break the sound barrier once, the fact is the universe breaks your laws and breaks the laws all the time. So I'm finding it really amazing. Like, for instance, to go interstellar would require us to go, if we think about it, if we think in terms of just staying within our universe itself, we would have to use the speed of light as the near maximum we could ever go. We could never go at the speed of light as, corporeal beings. We would be converted to pure energy at that point. Well, we have only been here for about 5,000 years of written history. If you go back to Sumeria and the cuneiform tablet language that basically was the beginning of our history, so to speak. And in that 5,000 years, we actually have seen ways to go interstellar that would take us to the nearest stars in just a few days, not in the 10 or 12,000 years that our current technology would take to get us there. So that's called the warp drive. And if you look it up, it's also known by the creator, Miguel Alcubierre. That's Alcubierre, Alcubierre. And Miguel Alcubierre came up with this process to be able to go these long distances by being able to have enough energy to warp space around you, like a black hole does. And then you can go the contracted distance, the shortened distance between you and your destination. And that would be a lot shorter distance than having to go the full length. Now, think of it as a piece of 8.5 by 11 notebook paper sitting flat on a table. To go from corner to corner is going to be a certain time and distance to go. But if you fold up those opposite corners by warping space and bring the points, the top left corner and the lower right corner, bringing them close together, and just jump over that little gap, well, now you get there in an instant, and you unfold space, and all of a sudden you're there. And you didn't even travel the intervening space along the paper across the diagonal area. So that is the basic process by which the Alcubierre drive works. You can think of it that way. And when the Froning, a guy named Froning, 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 actually added his 2 cents to the Alcubierre design, they figured out that not only could they get a very quick time frame to travel star to star, but in the process, should there be anything like debris that's in between where they do have to traverse, that debris will actually be shielded away and moved away by what amounts to shields, like in Star Trek. So it's kind of funny. Science fiction really has led to a potential science fact. And Sonny White down at Eagle Works Laboratories, I believe they're NASA funded, is funded to research the Alcubierre drive because he redid the calculations to figure out the amount of energy required, and they found out that the energy required to make this warp bubble that can actually warp space would be the equivalent of converting the whole planet Jupiter, the biggest planet in our solar system, to energy, and that's the amount of energy that would be needed. So, of course, it was colossally impossible and improbable, even probably for an advanced society. However, a rework of the mechanism by which that warp bubble is created showed that this warp bubble could actually be created with a huge reduction in energy. So no longer would we have to convert, say, the planet Jupiter to energy, which is, again, stupendously impossible. However, we would only need the mass, say, of the Voyager spacecraft. You can see the difference. Jupiter, Voyager spacecraft, Jupiter. I mean, come on. You can see the difference. It's obvious. That said, this obvious difference is why this is a funded project now, because it's actually distantly plausible, finally. That's pretty good for only being 5,000 years in our existence, don't you think, Daryl?
Yeah. Can I jump in there for a second?
You're part of the show.
it's amazing that they've got the mass down from Jupiter down to a Voyager spacecraft, but I don't remember offhand how much the Voyager masses or weighs. I do know that when I took high school physics, we converted 5 grams of matter, that's equivalent to a US 5-cent piece, into energy. And that one little nickel, that 5-cent piece, was equivalent to a healthy sized thermonuclear weapon.
That's right.
So think about converting all that mass of a Voyager into energy. You're still talking a huge amount of energy.
Right, but it's a 10 to the 24th or so reduction in power from requirement from, say, Jupiter. So it is a huge amount, and if you think about it, we're talking about Einstein's famous equation, E equals mc squared. And E equals mc squared, the m is the mass, c is the speed of light. So the energy requirement is, the mass of Jupiter times the speed of light squared, massive amount of energy required. However, if you find the energy is that much lower, then the Voyager spacecraft converted to energy is still very high. Still very high. However, it's something that is more doable than the previous. And that is, you see, that's how science progresses. It's crude at first. The crude prototype will probably function, probably do what it has to do, might explode on the pad for all we know. But the bottom line is we'll eventually get to where we're going. And that's what's going to happen. We're going to get to Proxima Centauri B probably first. That's what I would think. And we'd probably do it in about a week, by using such an Alcubierre drive. Now, there were some caveats to that particular propulsion, and that is that the propulsion used to get there could also be used as a weapon if it was utilized differently. And so we'd have to be very, very careful about what we do, because we could actually blow up the entire solar system because of the accumulated energy. It's like bugs on a windshield when you do this traversal with the Alcubierre drive. That extra energy would have to be bled off. But it would also be a suicide mission to whoever's going. So I think it's in our best interest to learn how to do that. And the Froning drive, the Froning variant of the Alcubierre drive, the Froning-Alcubierre drive, is the one that we would probably use. And I think that's the one that Sonny White's working on. So basically, I mean, that was sort of a little deviation, but we were actually talking about the diameter of the black hole. It would take us about 80 years to cross, 78 years to cross at the fastest speed we can travel. And that led us down the path of saying, well, the fastest speed we can travel now, but in the future, that is going to change. Now, we know that black holes have been known about for literally over 100 years now. And we talked about how light actually follows the contours of space when it's curved. So another way to look at it is if you take a bowling ball and put it on a plastic sheet that's been held taut, okay, the bowling ball is going to cause a depression. If you throw a marble out onto that and give it any speed whatsoever, well, if the marble is like light, as the marble rolls along, it's going to curve around and circle the bowling ball and come back. Well, we can actually get that to happen with light too. You could shine a light out toward a black hole and have it curve around and come back to you. The same light coming back at you. Well, was it reflected? No. It's the very same light beam. So you see, these are really strange creations, these black holes. And I think that it's really important to understand how these black holes function, but not important to understand all the fancy, crazy math to be able to make it function in your backyard, because I don't think we have to worry about that. But I know that, the black holes also have other caveats, okay? In M87, Messier 87, there's also these very, very large radio jets. What are those? They're jets of radiation and other material streaming off from the north and south poles of this black hole. And they're coming out of the galaxy, going out thousands of light years. Now we have some of it is moving at nearly light speed. This is that we call it relativistic speeds, and there's about 5,000 light years worth of this material moving at a relativistic speed. But there's also, not counting those parts, there's additional material that constitutes about 260,000 light years of material coming out from this galaxy's north and south pole of the central black hole. And that's the relativistic and the non-relativistic part. And now on top of that, the jet is also doing something called precession. It's precessing. It's spinning like a top. That is to say, these radio jets are spinning, and they're changing their position slightly, and they're dragging through space and creating these really interesting light shows. Now, we don't see it because it's so long term, but we'll talk more about that when we come back. We've already reached the end of our first hour tonight. It's going so fast. And we will talk about this procession when we come back. And I know that Daryl and Amanda have some fun things to add too, I'm sure. But this is Mark D'Antonio for Sky Tour Radio with Daryl and Amanda, and we will be right back.
Ray Sobbs here for SaucerLosAngeles.com, and I hope most of you by now have had the chance to go by and check out the Saucer clothing line, but if you haven't, go to SaucerLosAngeles.com. They've got clothes for men and women of all ages, even babies. All logos are embroidered, and everything is quality made right here in the USA. Go to SaucerLosAngeles.com now to find clothes that can elevate your state of mind because they believe in quality, durability, and they believe in style at SaucerLosAngeles.com.
You know, food was different 60 years ago. It was minimally processed, free of pesticides. It was nourishing and healthful for your body. Today, GMOs, pesticides, herbicides, and heavy processing have depleted the nutrition of our food supply, which takes a toll on our health and energy. It's harder than ever to get the right nutrition. That's what Life Change Tea is meant to counteract. Our specially blended, powerful herbal formulas can give you more energy without caffeine. It's a mild cleanse, a mild daily detox. A good detox can help revive and bring back the energy of your youth. GetTheTea.com is the website. It'll cleanse you from the inside out with this herbal proprietary formula. Go to GetTheTea.com. There's no fillers, no GMOs. It's organic. Not available in stores. You must go to their website, GetTheTea.com. And their supplements are a great way to maintain your health. Read the testimonials on the website. Go to GetTheTea.com. That's GetTheTea.com.
Your home has needs. It needs a healthy, dry environment all year round. Start by getting rid of the worst air in the basement and crawl space, where the problems begin and make the whole house sick. Introducing the new Smart Wave Ventilation Unit. It has advanced technologies to continuously reduce moisture, mold, and odors, and expel radon, gases, and pollutants. And now, Wave units include carbon monoxide detection to automatically expel air at a high rate and send you an alert. It also has an app so you can remotely monitor the conditions. Wave is a comprehensive, maintenance-free, affordable solution that will transform your entire home. Protect your home and family with what it needs. Give it a new Smart Wave Ventilation Unit. For more information, call 888-717-WAVE. That's 888-717-WAVE. Or go to dryhealthyhome.com. That's dryhealthyhome.com.
Wave Home Solutions for a healthy, comfortable home.
UFO TV All Access presents UFO Secrecy and the Death of the Republic, a movie that delivers a fresh analysis on the black budget breakaway civilization, the weaponization of space technologies, and the global UFO cover-up under the Obama and Trump administrations. UFO TV All Access is available on UFOTV.com, Roku, Apple TV, Fire TV, and Comcast. And download the UFO TV app from iTunes and Google Play. Go to UFOTV.com and subscribe now and see the movie UFO Secrecy and the Death of the Republic.
Now you have the inside contact for alternative talk radio. The Planet. KGRARadio.com.
Hey, welcome back to Skyter Radio. I'm Mark D'Antonio here with Amanda Curran and Daryl Mason. We are your astronomy trio for tonight on Skyter Radio. And I wanted to make sure that folks in the chat understood that I do answer questions that are in the chat. And Amanda has dutifully captured some of these questions. And before we start talking about precession of these radio jets and Mesher 87, Wow, you guys actually understood that too. Let's have Amanda bring up those questions so we can get to those first.
Yeah, we had one from Kathy. She wanted to know, how likely is it that hot blue stars would have planets with atmospheres?
That's actually a very good question. We talked about the ultraviolet radiation earlier as being something that sterilizes things like planets. And it turns out that these hot blue stars, O stars, for instance, they're so hot and they have such powerful stellar winds that it's probably unlikely that planets can even form around them, because their winds would produce so much radiation pressure that nothing would be able to become a cohesive sphere, say. The next line down in the spectral types there, the spectral classes, are the B-type stars. These are less hot, but still have copious amounts of ultraviolet radiation, and their stellar wind is also thought to be able to be so powerful that it can preclude planetary formation. Although, and I'm going to say this right up front, there have been stars that are B-type stars that show some kind of planets. They tend to be later B-type stars. What do I mean by later? A B0 is a very much hotter star than a B9. B0, 1, 2, 3, 4, 5, all the way to 9, right? So like the B8s and the B9s can sometimes have planets, and we know that the A stars, which come after them, and can also spew copious ultraviolet radiation, can also do that. So probably, to be solidly sure, you say from A on down to M type stars, those can have planets. Okay.
It's amazing.
Yeah, it's pretty cool.
It's very cool. It opens up a lot of possibilities.
Sure.
To think that I don't know.
Yeah, because our sun's not an M type.
Those percentages,
Yeah. Daryl, go ahead. You had sun?
Might I add that the hottest stars have such short lifetimes due to such a furious rate of fusion that they'd probably never have time to form planets anyway.
True.
You're talking millions of years is all.
Yeah. 10 million to 100 million years old, is about all they get. The brightest candle burns, for half as long, right?
Indeed.
Yeah. So you had another question, Amanda?
Yeah, we have one from Ronald. It's a little more specific. He wants to know if there's any exoplanets around the stars in globular clusters.
That's an interesting question, and the literature doesn't have a whole lot of information about planetary prospects around globulars, but let me give you an idea. Globular clusters have a special type of star in them, typically. These are stars that are very, very old, amongst as old as the universe in some cases, because they are very, very, very old stars. And they don't have a lot of gases in them other than hydrogen and helium. They make hydrogen into helium in their fusion processes, and that's about where it ends with some of these stars, or most of these stars in these globular clusters. So that means that if the stars were formed in such an environment where there was no other types of heavier elements, no carbon, no oxygen already formed, then it means that these stars likely don't have very many planets either, because the planets would have to form from something, and that something would also be in the stars if we looked at their spectra. But these stars don't really have a whole lot of what we call metals, anything heavier than helium. We astronomers call those metals. You go figure. It's like we don't really know what metals are. We're kind of silly that way. But the truth is we do. It's just that heavier than helium is sort of rare in a globular cluster situation. So we don't have a lot of planets that we see there. But it's interesting because we did see a globular cluster in Sky Tour live streaming the other night that was beautiful.
I wonder if that's where he got the idea.
I imagine he did, because he was attending, I think.
Yeah, so he's wonderful.
Are you talking about M3 we saw?
That's right.
Yes, that was beautiful.
Yeah, Measure 3 is a globular cluster, folks, for those who don't know. And Sky Tour live stream is the companion stream we talk about all the time with Sky Tour Radio. And we will be going live with the live stream right at the conclusion of the show tonight at 10 o'clock Eastern Time. So about 10, 12, 10, 15, we should be going live for a little while, and we'll check out some really cool things. So And then, any more questions, Amanda? We're done with that?
One more just snuck in, another one from Kathy. I'm not sure if it's follow-up or just in general. She wants to know, do the Pleiades have planets associated with them?
Oh, thank you, Kathy. The Pleiades are actually very hot blue stars, and they're B stars. And there's really no planets associated with these. Again, they have a lot of ultraviolet energy, and they are currently traveling through a cloud of dust, which is why whenever you see these really long exposures of the Pleiades, they have these clouds of dust around them. They weren't born there. They just happen to be traveling through this interstellar dust. And this, when I say dust, I mean dust grains. It's actually dust. It's not gas. It's actually dust. And so the dust scatters the light, just like the molecules in our atmosphere scatter the sunlight. And that scattered light looks blue, because blue is really efficiently scattered by the molecules in our atmosphere. And the blue is efficiently scattered by the dust grains in these clouds of clouds of dust. So that's why we actually see that. I hope that answers the question.
Yeah, I hope so. If not, I'm sure she'll let you know. And we were talking about dust last time we did a Sky Tour live stream.
Yeah.
What the dust was in the lanes and stuff. So.
That's right. In the galaxies, we saw these dark lanes.
Mm-hmm.
Dust is very prevalent in galaxies. And the only thing that's interesting is when we talk about these elliptical galaxies like Messier 87, what's missing is the dust. There doesn't seem to be a lot of dust in these elliptical galaxies. Maybe it's a consequence of how they're formed, whatever. But either way, we don't see a lot of dust in these galaxies. In spiral galaxies, which have those spiral arms like you're familiar with, many of you, these spiral arms usually have dark dust intermingled with knots of star formation going on. Very, very complex locations. Ellipticals seem a lot simpler. But most galaxies have these supermassive black holes at their center. And our own galaxy does as well. And I did a talk for, I think we had like almost 800 people down in Arkansas when I was just down there. And what I showed them was, in fact, Sagittarius A, the central black hole in our own galaxy. And you can actually see the stars orbiting. It was a 10-year study. And over 10 years, you can actually watch several of the stars orbiting the central black hole in our galaxy. You see them orbiting something that isn't there. I mean, it's the most spectacular image and video I've actually ever seen. So I include that in my presentations now to show people, when I see a black hole, here you go. What's a black hole? Well, it's where light isn't, and that's exactly what we see there. Really, really cool.
And
now,
you showed that on Sky Tour live stream as well.
What's that?
You showed that on Sky Tour live stream as well.
That's correct.
That little video of the.
Yeah.
I remember that one. Was it a star? Maybe.
Yeah, that was whipping around the center.
Whipping right around the bottom. Yeah.
That's right. That's right.
Well, when it comes to that, I'm still not sure if it's like a star or just a particle, like an atom.
No, we're looking very, very far away. We're looking at whole stars.
Yeah.
In fact, they could have, star systems have many planets for all we know, but we haven't been able to see that yet. I mean, maybe they haven't been in a research program to look for transits and whatever on these stars. But, it looks like they're moving fast in the video, but that's taken over 10 years, So,
how would a planet around one of those stars whipping around a black hole ever survive going that fast?
Well, it goes that fast because it's basically time lapse. You're watching it over a 10-year period. So as far as the planet and the star are concerned, it may not be getting close enough for the planet, for instance, to get dragged away by the black hole. But I guarantee you that if it gets close enough, it will disrupt that star system. And any planets in that star system will get disrupted. Because that's very powerful gravity that they're being subjected to. Because it's going to be a lot more massive than the star itself.
I don't think I'd want to be on that planet.
No.
I think I wouldn't either. I'd rather be on a planet. Let's see, a planet that had lots of strawberries that are orbiting, lots of strawberries covered with chocolate. I think that would be a nice thing, don't you think? We have a strawberry shortcake solar system or star system. I like that very much. Yeah. Can you tell that I want some strawberries?
Yes, I can.
Yeah.
Okay, sorry. Yeah, I probably shouldn't have said that, but hey, I like
Just to
it.
make sure everyone's paying attention.
And strawberries aren't berries, by the way. Just so you know, that's not really what they are. I guess they're kind of like a fruit, really, aren't they? More than a berry.
I thought berries were fruit.
No, no. A peach is a fruit, A berry's a berry. They're different. But anyway, I don't know. Daryl, weigh in on this. What do you think? Are strawberries a fruit or are they a berry?
Well, it says berry right on the end of it. I mean, we grew up eating strawberries, and I think of them as berries.
Yeah.
I think maybe the geek's coming out here a little bit, Mark.
Yeah, maybe. I guess maybe. Because calling them straw fruities doesn't really sound too good, huh? Strawberry, straw fruity. I don't know. It sounds like flavors of strange yogurt. Okay.
I can give you a tip for the day. Do you know who Alton Brown is? He's the guy that did Good Eats on the Food Network. One of the most important things I ever learned from Alton Brown: when you go to the store, smell the strawberries before you buy them. If they don't smell like strawberries, they won't taste like strawberries. Think about that.
Interesting. I don't want to smell a black hole though, because that if I go to stick my nose near the like Mesher 87's black hole, it'll get removed from my face and I'll be moved into an infinitely long string of fleshy goo that would then basically, to an observer, never look like it's going into the black hole. But to me, I'd long since have been destroyed by the black hole. Yeah, that's one for the folks out there that have that intellect running about how black holes operate. If you know anything about black holes, they're very dangerous places, frankly. And Mesher 87 is no different. Thank you for that tip, Daryl. I now am going to look like a fool the next time I go shopping for strawberries.
Hey, I do it every time. I get funny looks sometimes, but I know what the heck I'm doing now.
Okay. All right. Well, you heard it here first, folks. Smell your strawberries to see if they smell like strawberries.
Let's talk about black holes.
Yeah. I'm glad this didn't apply to turnips. I hate turnips. But anyway, when we were talking about the Mesher 87, we were talking about the sheer strength of that black hole and how the north and south pole of that black hole actually has these gas and radiation that's emanating from it. Again, caused by the complexities of the event horizon and what goes on there, the tight interaction of the accretion disk of materials spinning around the black hole in that plane. And material shoots way out, and we said that some of it goes to relativistic speeds. That means near the speed of light. And that material is a material that is in length. It's about 5,000 light years worth of length of this relativistic material. However, for the non-relativistic parts, that is the stuff that's not moving near the speed of light, you have a total that's around 260,000 light years in length for these jets. It's amazing. And that is way outside the galaxy itself. So clearly, this is an active galaxy doing some amazing stuff. All right. Now, what's also happening with these jets is that just like a spinning top that wobbles as it begins to as it's moving, you notice the top of the top of the spinning top wobbles a little bit, a little circular pattern. That's called precession. And the black hole itself is actually precessing and causing these jets, these massive long jets, to be dragged out in like a spiral. And Daryl used an interesting analogy before. He said like a sprinkler where the water is whipping around. And that's kind of what this looks like, And in the chat, I think Amanda put a picture in that shows the jet, the relativistic and non-relativistic jet. And you can actually see this precession captured on camera. It's not moving, okay, but you can actually see the precession as imaged by, I believe it was the Hubble Space Telescope for that, right? Daryl? Was it Hubble?
The APOD picture you got me to link.
Yes. I'm not sure if that precession pic, he's talking, if you see the picture, folks, that's the inset at the upper right. You can see the jets precessing. have kind of a spiral shape to them.
Might have been Chandra.
I don't remember who took that.
That could have been the Chandra X-ray telescope as well, but that would only be for the very high energy parts of the jet. But
right,
or it's radio telescope. I mean, there's radio frequencies in there too. So, yeah, I'm telling you guys, this black holes are really, really odd places for being so small. The central part of the black hole is a singularity. Supposedly, it's an infinitely small point. And then the event horizon is just that point beyond which the gravity becomes so strong that light can no longer circle away from the black hole and get out of it.
This image is from the Spitzer.
Oh, Spitzer. Okay, so it was infrared. All right.
Okay, I see there in the caption now. Thank you, Amanda.
Okay. Yeah, 'cause that material would end up being heated up quite strong from the high energy radiation. So that makes sense.
May I jump in here? If you look at that image, the first inset a little bit to the upper left of center, well, if you look at the big picture first, with the first inset inside it, you're seeing M87. Now, Mark has shown us M87 many times, and we had a really good look at the jet on the right-hand side the other night.
Yeah.
What we were seeing in that image that Mark created is more like what's inside that first inset, a little bit to the upper left of center. There's a whole lot more galaxy all around. You see in the bigger picture that was too dim to see through the camera and the exposure time. I dare say a longer exposure might capture more of that. But then when you jump over to the second inset there at the upper right, you can see both jets. The one on the left we can't see visually, but you can see both jets coming out the south side on the left and the north side on the right, and you can see the shape of them where they are precessing. If the jets are precessing, I have to guess that the black hole itself is precessing. And geez, what would make something with 6.5 billion solar masses precess? I may talk a little bit more about that in a bit. Then the inset at the bottom right, well, of course, you're seeing the recent event horizon black hole image. Zoomed to proper scales, I assume.
Yeah. Now, I would say, what would give something that massive precession? And I put it to you that it wasn't that massive when it was precessing. I think that the mass was acquired over time. But I think that once it's precessing, there's no reason for it to stop when there's more material infalling. In fact, that infalling material might actually maintain the precession. So what am I saying? I'm saying that when this first formed, this black hole first formed, I don't know whether and I don't think anybody does, whether this supermassive black hole was formed at the beginning of the universe or whether it was formed from a fairly large supernova. And then, that became the seed object to become the central black hole in this galaxy. I don't know. I don't know how that actually happened, and I don't think anyone does actually. But when we talk about the precession, stars, remember, are rotating. Our sun rotates on its axis. It rotates just like the Earth rotates on its axis. And if the original star was rotating and then it went supernova, then that would impart some potential angular velocity or angular momentum that make it spin up more, possibly, and that could be what's responsible for this precession. It could actually cause the spin, depending on how the explosion occurred. It could have possibly caused the spin to go from being a perfectly spinning object to an object that was wobbling to begin with. And as it acquired more mass, it would just continue to wobble. And that's when it made these relativistic jets that came off, these one amazing big jets of material. Those too would wobble. So I think that it probably wasn't this large when it began to wobble. It was probably wobbling from the very start.
I understand what you're saying. I know we talked about this earlier, Mark. I want to throw out an alternative there, though. I showed you earlier, and I shared the links with Amanda. She can post when she likes. An article I found today, and a YouTube video about very recent results, further results from the Event Horizon Telescope. The article, it's a scientific paper. It's where they measured how fast the black hole is spinning in M87, and it's 11 pages. There's a video also. It only takes 11 minutes. Please watch them later at your leisure, where the guy explains the scientific findings of the 11-page paper. They state that the 6.5 billion solar mass black hole is literally dragging space-time with it, dragging space-time around it. Sure. I wondered if this could somehow be the cause of the precession. This is getting over my head, but well, if the black hole can actually drag space-time with it, maybe space-time is dragging back on the black hole, you know, and maybe that's causing the precession.
Yeah,
I really have no idea.
I think the word drag kind of implies that it's causing drag on the black hole. I'm not convinced that's what's happening, though. And I'd have to actually read that. Actually, you know, fair warning, I didn't read that yet, Daryl. So
okay.
He did send it to me, folks, and I didn't read it. I am remiss. I was actually writing more of the script tonight. But I did want to mention that this black hole precession is really it's quite a ponderous thing. There's a lot going on there, and what I think is happening is with this massive gravitational field, as it's precessing, yes, it's going to also warp the fabric of space as it precesses. But does that mean that that's putting a drag on the black hole? If so, wouldn't that be slowing it down? And that's the thing. See, if it's doing that, yeah, it should drag it, slow it down. So shouldn't it have slowed down dramatically since its formation a long, long time ago? Maybe it is. Maybe it's a lot slower than it used to be. I don't know.
Well,
we have to consider that, right?
Yeah, sure. If you just watch the video, it gets good at about the 3-minute point, and the guy gets into the meat of the issue. He states in there, and again, this kind of goes over my head, but he said like the instantaneous energy in that black hole, which I assume, and I think he does compare or says eventually is angular momentum. You know, the thing has the energy of like 50 trillion supernovas, average supernovas, if you can call a supernova average.
Yeah.
And right. That is one heck of a lot of momentum, angular momentum. It's like a flywheel spinning, you know, that, yeah, maybe the word drag was a poor choice, but it is carrying space-time along with it, pulling it around it. Yeah. And maybe space-time is pulling back. But that flywheel is going to maintain its momentum for a very long time.
Well, for sure. But we also know that pulsars that are neutron stars that are not quite going to black holes are the central remnants of other supernovas that are slightly less massive. Pulsars also have a certain rate of rotation that's actually colossal. The record is over 700 times per second that a Manhattan Island-sized stellar remnant spins. 700 times per second. That's massive. And that spin is something that is impossible to understand. However, pulsars slow down over time, and they actually do slow down. Their spin down times are very, very, very long, of course. And black holes, on the other hand, they have another property that they go through, and that is if they don't gain any more mass, they eventually begin to lose mass. They evaporate. So a small black hole, for instance, if you call a black hole small, to be a black hole, you have come from a large star to begin with. But a black hole smaller than these supermassives, that would definitely be something that would evaporate away over time if nothing else interacted with it in the universe. If it doesn't gain any more mass, then it will eventually shrink and then evaporate and vanish.
I remember reading Hawking about that, and aren't you talking like timescales of trillions of years, though, for a black hole to evaporate? And it does depend on the size.
Yeah, and don't forget that there's also a theoretical micro black hole, which I think would be like the remnant of a black hole that had been here for a long time and was already evaporating down to a much smaller. And that's why we're talking about it, because these are very interesting concepts. The whole concept of the black hole, it quickly takes you into quantum physics from normal physics. I call it macro physics, and at the event horizon, there's a ton of things that go on. These jets of high energy radiation that are spinning around there. That event horizon, the energy is given off, by the black hole, and that's due to something called Hawking radiation that Stephen Hawking, of course, is famous for finding and discovering.
Yes.
And like I said, they will evaporate over time unless something comes in and adds mass to the black hole. There's a lot of physical properties, for instance, that are demonstrated by these black holes, and we're going to talk more about those in just a few seconds after we break for commercials here on KGRARadio.com. I'm Mark D'Antonio. This is Sky Tour Radio with Daryl and Amanda. Be right back.
Balance of Nature's fruit and veggie capsules contain 100% fine-ripened fruits and vegetables, tested pure with no pesticides, fillers, or additives of any kind, and are the most effective whole food supplements on the market today. You might ask, how can over 10 servings of 31 different fruits and vegetables fit into 6 vegetarian capsules? Fruits and vegetables are on an average 85% water. Balance of Nature uses cold vacuum technology to remove the water, leaving only the whole food. We don't use any heat, air, or light drying methods that damage nutrients. Our cold vacuum technology maintains 99% of the fresh fruits and vegetables' original nutritional value. Along with diet and exercise, Mother Nature provides fruits and vegetables to help us maintain good health.
To order, go to balanceofnature.com or call 1-800-246-8751. That's 1-800-246-8751 and use discount code TALK.
There are many sounds in your day-to-day life. There are sounds that wake you up. Sounds that make you smile. Sounds that energize you. And sounds that help you relax. But there are some sounds that can alert you to danger and can help save lives. Wireless emergency alerts, now on many mobile devices, use a unique sound and vibration to bring you information about severe weather events, Amber Alerts, or other emergencies in your area. With critical information from local sources you know and trust, you can be in the know, wherever you are. For more information, visit ready.gov/alerts. Brought to you by FEMA and the Ad Council.
Join me, George Norrie, in Indian Wells, California, for the 7th Annual Contact in the Desert UFO Conference, May 31st to June 3rd. Contact in the Desert is an epic weekend of adventure filled with exciting explorations into ancient aliens, human origins, crop circles, UFO sightings, disclosure, and the newest evidence of ongoing contact. This amazing weekend offers over 50 lectures, 40 workshops, 8 exciting panels, special events, and a luncheon that I'm hosting. Contact in the Desert also features leading experts including Giorgio Tsoukalos, David Wilcock, Linda Moulton Howe, Michael Tellinger, Eric von Daniken, Doc Wallach, and many more important researchers and scientists in the field. Contact in the Desert is your place for inside information. Join us at thecontactinthedesert.com to get your tickets today. It's time to make contact. That's contactinthedesert.com. Don't miss it. Contactinthedesert.com.
You listen to us, and we listen to you. And so does the CIA. KGRARadio.com.
Hey, welcome back to Sky Tour Radio. This is Mark Antonio with Amanda and Daryl, my wonderful co-hosts here on our wonderful astronomy show. I gotta say, a big thank you to KGRA, because KGRA took a chance on us and asked us to do an astronomy show on a paranormal radio station. They almost don't go together, but I want to say that so far, the response from all of you has shown that, yes, people are hungry for science. They want to know. And, we may delve into the science of paranormal activity and what we think could be happening there at some point. But again, we are primarily an astronomy show. And once we start talking about parallel universes a little bit more, and some of the experiences I had, which indicate to me that we do have possible parallel universe activity going on, I think that'll be another point where there'll be a nice connection between the folks that listen to KGRA for the paranormal side can appreciate some of the science that we do. Now, in our last segment, we talked about precession of these gigantic, massive jets of radiation and matter. Actually, they're spewing out from the center of the Messier 87 galaxy in Virgo, where the black hole was found. And at black hole levels, this precession, this swirling, this spinning like a top motion that is caused or happening inside this galaxy makes these massive jets of radiation swirl like turbulent water. Okay, turbulent water as they lash out at space all around them. Now, on smaller scales, we have precession that can cause other possible anomalies, like the Earth has a precession as well. Every 26,000 years, the Earth goes through this circular cycle. It spins very slowly like a slow-moving top. And precession, it's precession, causes the pole star to change position. We see a different pole star because the top of our planet is pointing at a slightly different location as it spins around, and the top, spinning top moves a little bit more and more over time. So now, as the Earth is doing this precession, and as it's rotating, we have to keep in mind that the entire time this is all happening, deep inside the core of the Earth, we have a core that is solid of iron and nickel, and we have an outer core which was molten iron and some nickel. And the molten iron is rotating as the Earth rotates against an inner core, that inner solid inert core. And they're rotating at slightly different rates, and that actually generates some massive electrical currents. And that translates to causing a magnetic field to appear over our planet. So that magnetic field, of course, has made life possible on our planet because it prevents, as we talked about with Proxima b, it prevents the ultraviolet radiation from reaching the ground and sterilizing and killing plants and other creatures. So I think that's pretty interesting. Now, if we look at our historical record, and by historical record, I don't mean history books, I mean the rock strata coming off the mid-Atlantic ridge in the middle of the oceans, we see that there is a record of the Earth's magnetic field. And this record of the Earth's magnetic field shows that we have had the north and south poles switch periodically. Now, that's called pole shift in the typical parlance as you see it on the internet. All right, and that pole shift, it doesn't mean that the Earth flips upside down. That's just popular hogwash and fake news that you hear sometimes. And sometimes people don't understand it, and they say, "Oh, well, the Earth's going to flip upside down. Everyone's going to die." Okay, well, I don't know why they're in such a hurry to die. I'm certainly not. Okay, I just got back to life. So, but it doesn't mean that's going to flip upside down. It just means that your compass is going to start reading progressively different and more different north and south readings. And then eventually, perhaps, your south pole will read as our north pole and vice versa. So that'll mean that the south pole will end up, in other words, being near the Arctic Ocean and not Antarctica. All right. Now, how that happens is not entirely understood, and it has a real name. It's actually called geomagnetic reversal, and that's something that is related to this dynamo in the center of our planet. All right, the center of our planet, this dynamo, and it's actually, when it creates these vast electrical currents, and they're caused by that flow of that liquid metal in the outer core flowing around that solid inner core, all right, like we talked about. And sometimes, for reasons we don't understand, the flows change. They change the way they flow, the direction they flow. And these changes will actually cause the magnetic field to change. And this is sometimes, it's a very complex thing. And there's actually a map showing the current map of the Earth's magnetic field. And based on the way the Earth's magnetic field looks now, we could already be in the middle of a geomagnetic reversal. It could be happening now, And basically, people know that depending on the rock strata under your feet, wherever you go in the world, you can use a compass and it won't always point to north. And the thing is, these reversals are caused by this complex motion that's going on around the outer core. All right. And again, contrary to popular doomsayer belief, they're random events. They don't occur every so often. We're not, quote unquote, overdue for one. So when people say that to you, you just tap them on the forehead and walk away. Okay. And say, okay, I'm done with you, and just walk away, because they're frankly not speaking properly. They don't have an understanding of what's going on. So they don't happen on a regular basis. They're random, all right? So, and I'll give you an idea, okay? The rates of these reversals over in historical times have varied tremendously, all right? And here's an example. 72 million years ago, there were 5 field reversals in a million years, starting around 72 million years ago. Five of them in 1 million years. Around 54 million years ago, there were 10 geomagnetic reversals that occurred over a 4 million year time period. All right. And now, how about this? 42 million years ago, there were 17 geomagnetic reversals in just 50,000 years. You see? And the last reversal was 780,000 years ago. Now, then there's times where no reversals occur for many millions of years. These are called supercrons. All right. Supercrons, CHRONS, supercrons. And these supercrons can last for a fairly long time. And when a reversal is underway, all right, the time it takes for a reversal to occur, to go from, say, one pole to another, roughly, can be anywhere from 1,000 to 10,000 years on average. Okay, now there's some surprising statistics, though, that are kind of interesting to talk about, and that is that the evidence indicates that there was at least one reversal which occurred over a much shorter period, perhaps in as little as 200 years to make the transition. Okay, and still other evidence that indicated, well, maybe it took place over the course of one human lifetime. Now, the doomsayers will say, oh, this will doom us, and they love to tell you how life on Earth is going to be extinguished from such an event. The truth is that the birds will keep flying. The GPS will just be subtly adjusted day to day if necessary. Okay, and we'll just keep on living. And the fact is, the magnetic field strength has been in doomsayer talk is going to be reduced to nothing. Oh no, it's going to let all the ultraviolet in and kill us. Well, guess what? That's absolutely untrue for a number of reasons that we can go into, but primarily the Earth's magnetic field is going to continue unabated for quite some time, even with reversals, because many reversals have come and gone already, and it didn't basically be coincidentally at the same times as anything else where there were major extinctions or anything else. It's just something that happens. The Earth manages it and will be subject to it because of our technology. If we didn't have technology, we wouldn't even know, and we wouldn't even care. We wouldn't see anything any different. The sky won't change color. The flowers won't grow upside down. People won't start walking backwards going, hey, what happened? There won't be anything like that, okay? So, these Earth doomers, as I call them, will also love to tell you that these reversals are imminent and overdue. Don't forget. And I always say, well, how can a reversal be overdue when it's random to begin with? It can't be, and it's not. So right there, shut that right down right off the bat. See this?
There?
Yeah, go ahead. Darryl.
We may see more auroras if and when it happens. I've heard that said, at least, that we may see more auroras. They may come down to lower latitudes where they're visible farther south. That would be nice to see if it doesn't mean anything bad.
Yeah, I remember in the 80s, I was at a movie with my sister's kids, kind of babysitting. And it was a drive-in theater, and they were, of course, enjoying the drive-in. And, hey, look, we're lying in the back of this car, checking this stuff out. Look at it, wow. And looking up in the air, I suddenly saw this aurora over my head. And I was like, whoa, this is Plainville, Connecticut. And this is like, it's fairly brightly lit around the town. I see this beautiful aurora over my head streaming like I'm looking up into an umbrella, of stuff streaming. So the radiant, that is where the source of it was, directly over my head. I ran to a phone, left the kids in the car. I called the hotline down in Washington, D.C., reported this aurora overhead. Okay, came back to the car. Uncle Mark, where'd you go? I said, no, don't worry, we got to go. So we left, and I ended up taking photos for the rest of the night of these most beautiful auroras I've ever seen in my life that were happening down here. So they're beautiful. You saw these beautiful green ones, and by the end of the night, horizon to horizon, by 3 a.m, horizon to horizon was a pink salmon glow, like we were on Mars. Pink salmon glow, horizon to horizon, every direction you look. It was like that Star Trek episode, "For the world is hollow and I have touched the sky." Same color, except for they didn't have the same sound of the plants, like you have in Star Trek, but it was really cool. So we might see more auroras, and again, that would have to coincide with more solar activity as well.
Well, we're at solar minimum right now, and we're seeing tons of auroras. Farther north, of course. We had a spectacular run of auroras back in the 90s that were visible here in Colorado.
Oh, sure.
They were spectacular. They were great.
Yeah. And you're going to send me photos from the photos that you took?
No, I don't have any photos. Sorry.
Oh, well, then you know what? It didn't exist.
Yeah, I was hallucinating, I guess.
Yeah, no. So the question is, you'll hear about this silliness of the geomagnetic reversals, and the doomsayers will come out in force and say, "Oh, we're all going to die," because that's what they want to do. They want to get clicks on their videos. But you know what? Like I said, just join Sky Tour live stream or come up and listen to Sky Tour Radio, all things Sky Tour, and you know what? You'll hear what's real. All right, between me and Darryl and Amanda, you'll know what's real. Okay. But
don't listen to me. I talk in hypotheticals.
But your hypotheticals are more informed than some people's for sures.
And you have come so far, Amanda. Like I said on the last stream, you asked very intelligent questions.
Yeah,
you have learned so much.
Well, it's great because this way, listening to you two talk, when I hear the discussion, then it gets me thinking. So,
yeah,
I really like this combination. I hope the listeners do too.
Well, technically,
I think they do.
Technically, I used to teach people. I actually taught everything from kindergarten to college. Okay, wow. Believe it or not, I taught kindergartners how light works, and they got it. Okay, they understood because the way I showed them. And frankly, I think that science is within reach of every single person on the planet. I wouldn't try it with 2-year-olds, but 5 and 6-year-olds, yep. Mm-hmm. I can have them understanding what light is and go home and say, "Mommy, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet." I'd have them saying that by the time they got home, and their mothers would say, "What the heck did you teach my kids? Who's this guy, Roy?" Well, it's red, orange, yellow. Well, anyway, in terms of what we're talking about, I really think that, the doomsayers will say their things. They'll say what they want. The truth is, we'll come out and tell them the truth. We'll tell you the truth. Look to us. We'll help you. But geomagnetic reversal is a real thing when it happens. And we see a lot of it in the historical record, in the fossil record, looking at iron compounds from the Mid-Atlantic Ridge, because the Mid-Atlantic Ridge spreads several centimeters a year. And as it does, the iron crystals in the magma that's arising, coming out of there, align with the current state of the magnetic field at the time. So we see them moving up and down, up and down, up and down throughout millions of years, as I said, all right? And we see these bands where the crystals go one way and then they go the other way, the one way, the other way. That's geomagnetic reversal occurring, okay? Well, guess what? The sun also has something like that going on, because every 11 years or so, the sun goes through a period where it has this intense sunspot activity. And what is that? That's where the magnetic field lines, the magnetic field of the sun is getting all basically confused. And where these knots burst through the surface, they create these sunspots and solar storms. And thus, after that, it realigns. And now it's at a point where it's realigned. And thus we have this quiescent time frame for the sun, this quiescent phase, where not much is going on. And you get the occasional knot popping through and sunspots, but still, for the most part, the sun is more quiet. Well, same thing will happen to the Earth, and during these supercrons, these times when there's no, geomagnetic reversals, well, then, a lot of things can happen evolutionarily, and I think that, creatures that use magnetic fields for navigation and so forth, they slowly adapt or they perish. Okay. And that's what we're seeing, creatures will adapt. And the Earth is full of creatures that are marvelous at adapting. I mean, you just look at some of nature, specific adaptations for specific food gathering principles. I mean, I am amazed, I mean, a spider web is one obvious thing, but creatures that mimic other creatures, okay, to specifically trap one type of creature. Now, that's incredible, right? But that's stuff that's evolved here over time. Now, in terms of the geomagnetic reversals, okay, when we ask, say, what can cause them, well, let's remember the magnetic field generation by this dynamic planet is really important. The inner and outer cores, the electric field is generated, the magnetosphere is the result. And that magnetosphere traps these high-energy particles from the sun and creates something called the Van Allen belts. And these belts will be higher in altitude or lower, depending on the solar activity. And this is something that we've always been concerned with for satellites. And again, to the doomsayers, the Apollo astronauts bolted right through the Van Allen radiation belts with no problems whatsoever. Okay, and so, yes, we can get through the Van Allen belts. We've had satellites that have gone through them. None the worse for the wear. Yes, we have to take precautions. We do. They're fine. End of story. Okay, but, if you want to persist in saying stuff that isn't true to get clicks on your YouTube account, well, I guess I can't stop you doing that. But, you can always make a comment, those of you that are intelligent on those videos, and say, this is baloney, this isn't true at all, and here's why. And you can tell them to talk to me if you like, or Daryl, or Amanda. I'll make sure that everybody understands what's going on if they don't already. Now, some of the scientists that are involved in geomagnetic reversal research think that some of these can be triggered. Maybe extinction-level events. Could a colliding asteroid striking the Earth cause enough disturbance to our magnetic field that it might change the motion of the tectonic plates, might cause some deep mantle disturbances that could affect the outer core's rotation and thus magnetic field generation? Well, that's a good thought. And if you think about it, depending on how deep the asteroid penetrates, I'm sure it could. If it penetrated the same depth that was required to make the moon, where a Mars-sized object basically turned the entire planet back into a molten slurry as the moon blew out of it, well, then I'd have to say that that certainly would have disrupted the magnetic field and probably is responsible in part for our precession that we have. But you got to remember, we are dynamic, and could the motion of the tectonic plates cause this reversal to occur? We are on floating plates of hardened lava that move around, they crunch against each other, and where they meet, one plate might dive under one and one might ride up on top of the other. That diving plate is called a subducting plate, and that's actually a subduction zone at the edge of the plate. That's where you see a lot of volcanoes. The Pacific Ring of Fire is a subduction zone around the entire Pacific plate, where you have all the volcanoes there. And these cause a disturbance, possibly in the electrical currents that are being generated by the core dynamo. Right? Is that possibly what's causing it? Okay. How about new plumes? These new mega plumes from the outer core into the mantle. These large plumes of hot material that are moving up. Could those cause geomagnetic reversal? We know what plumes are. There's large plumes. There's small plumes. I'll give you an example of a small, lesser-sized plume. Crustal plates travel across the mantle, and these hot spots in the mantle poke through and make volcanoes, sometimes in the middle of one of the crustal plates. Okay? Now, because hot spots stay roughly in the same place in the mantle, the crustal plate is shifting over that top. And as the crustal plate is shifting over the hot spot, we'll see that there'll be some intrusions into the mantle material, into the crustal material from the mantle. And these are really far from the crustal boundaries. Now, do you know, I'll give you all a chance to answer here, Daryl and Amanda, do you know some of the famous hot spots on our planet?
Yellowstone.
Yellowstone is correct. Amanda, do you know what? You have one?
No.
Okay. Daryl?
Hawaii.
Yep, Hawaii.
I was going to say Hawaii, but I didn't know anywhere specific.
Shame on you. You see, your first inclination is usually the right one. You should say it.
The Yucatan?
And that's actually was the site of the impact, but that's a good thought. I mean, could that asteroid impact have caused the geomagnetic reversal by impacting? We didn't see a reversal at that time, so it doesn't look like it did. Okay.
Is Canada one? Anywhere in Canada? It's a pretty big country. There's got to be one here.
Well, Iceland, actually.
Oh.
Iceland is another one. Believe it or not, there's about 10 or 20 hotspots in the world where the mantle plumes reach up into the crust of the Earth and cause volcanic eruptions in the middle of these tectonic plates. Now, you mentioned the Yellowstone supervolcano, Daryl. The sheer power of these mantle plumes is immense. The North American plate is heading southwest, and 12 million years ago, the Yellowstone caldera at that time was actually located under Idaho, because as the plate moves southwest, it finally worked its way into Wyoming, and the hot spot stays at the same place, and the plate floats over it. So it was Nebraska, it was Idaho first, and then it became Wyoming. But when it was Idaho, over 6 feet of ash ended up in Nebraska, 1,000 miles to the east. That's 1,600 kilometers eastward. All right, when that volcano went off. Okay, and the Hawaiian hotspot gave birth to the Hawaiian Islands, and that plate's moving northwest. So that means Hawaii, the big island, is the youngest. The North American plate's heading southwest, so there's collisions along these plates, and these cause the earthquakes that we see, the San Andreas Fault and all the many faults out there. And, in the Hawaiian Islands, the oldest island is the westernmost island in the chain, so Niihau and Kauai, right? And that chain, by the way, if you trace it on the ocean floor by looking at Google Earth, you can see that chain goes all the way back to Kamchatka, okay? Up there in the just to the west of the Bering Sea, okay, all the way up to Kamchatka. Isn't that incredible? So you're watching the tracks of the plates moving on the ocean floor, and what are we looking at? We're looking at where these hot spots are poking through the crust a little bit, and many of them never get to the surface. Many of these hot spots, they poke through and they make a little what's called a seamount, an underwater mount that was a volcano that ended up going dormant, of course, and then. That's because the plate rolled by the hot spot. And that kept happening, and you can see the path that the plate has taken. So in the end, okay, the evidence actually does not show a link between any of those previously mentioned things and geomagnetic reversal. We simply don't know why it occurs at this point. Stratigraphy, the study of the rock strata, shows no correlation between impacts, tectonic motions, or hot spots with reversals. So we're left to wonder why it happens at all. But we do know that the next time it happens, we're going to be just fine. Nothing's going to happen. Birds aren't going to suddenly smash into buildings, go, what happened to my magnetic field? And boom, you're not going to get that happening. Okay. So once again, we're basically left to attribute these to these giant global changes in the molten rock flow that alters the currents and changes the magnetic field. So these geomagnetic reversals are something we've lived with for millions upon millions upon millions of years. Life persisted, life continued. In the Permian era, 252 million years ago, we lost 96 to 98% of the life on this planet. And dinosaurs, in fact, reptiles, were selected for success at that point, and mammals were not. And then we ended up re-arising after the Cretaceous Paleogene boundary event, the one Amanda just mentioned off the Yucatan, where that asteroid impact occurred. So life will persist. We've persisted, and we're going to continue to persist, as far as I'm concerned. And with the creation of the Alcubierre drive, we will find ourselves leaving this planet sooner or later and heading to the nearby stars. Maybe Proxima b. Tidally locked or not, life could possibly still exist there to bring it all back to the very beginning. So I just want to thank you guys for going on this journey with us. On behalf of Daryl and Amanda, I want to tell you that you're welcome to join us on Sky Tour live stream in a little while. The observatory is open, and we're going to start checking it out. We're going to look at the sky tonight for a little while, and we'll look at some of these things we've talked about tonight. But so, just to keep in mind, the next time you look up, just think about it. We're on a life-giving planet, and out there is going to be another life-giving planet, maybe trillions of them. We know there's more planets than stars. So as dark as the night is, and as many stars as you can see, there's always more planets. All right. Have a good evening, everybody, and we will see you the next time on Sky Tour Radio.